Hello and welcome to episode 4 of the weekly AI Yap, where I just talk about this week's past news in AI and my thoughts on it and just kind of go on tangents about AI. So this this week the kind of big news is the new Intel and AMD CPU announcements, and also that's kind of it. Maybe you can talk about the OpenAI benchmarks, but not really, right? And so I think this episode is going to be a lot more hardware focused, right? Talking about the different hardware that's coming out and whatnot. And so I think we're going to start with the OpenAI stuff, which is they released a benchmark. It's a cool benchmark, amazing. Now onto hardware. Both Intel and AMD announced their new hardware for this generation, right? Because they release new hardware every year-ish, but really every 2 years that the actual jumps happen. And so both Intel and AMD have released hardware they've kind of re-architected their hardware, so they've not really gained any performance. They've gained efficiency, right? Intel's claiming a 50% efficiency gain. The desktop CPUs actually have neural processing built in, so they have 13 teraflops of neural processing built in, right? And so that's really good. And AMD also has the new CPUs. I'll talk about the GPU stuff a little bit later, right? I guess also the NPU stuff a little bit later as well, right? And so just on the CPU side, Intel has killed multi-threading, right? Multi-threading is dead. And so in essence, what you have now is you have more power efficient cores. And I actually think this focus on power efficiency is actually really cool. Because, okay, the thing about silicon, right, is that you kind of can only use a certain amount of it at the same time, right? Because the power density of the chips is just very high, right? And so right now, the limiting factor for basically all chips is thermals, right? It's not raw performance, right? And the point where you get to raw performance is a bottleneck, you're not really seeing that. It's all thermals being the bottleneck. And so what Intel has done is Intel's kind of killed hyperthreading. Their P cores no longer have 2 threads per core. And so now, in essence, what you have is if you take, say, the i9, or I guess Core Ultra 9 now, because they've also redone the naming. I'm going to call it the i9, right? I'm going to call it the 15900K, even though it's actually the 285K, whatever, right? So because the 14900K was the previous i9, and the 15th gen 15900K is the new i9. The old i9, I believe, had more threads, right? Because that one was also the 8 P-core, 12 E-core, and 28 threads, because each P-core was 2 threads. But now you have 8 P-core, 12 E-core, both of which are not multi-threaded, so you only have 20 total threads now. However, these threads will be more efficient, right? They will be more power efficient, there'll be more of all of that. And so, in essence, multi-threading is dead on the Intel side. I'd expect something similar from the AMD side sometime soon, but AMD is still doing hyper-threading. Multi-threading is not dead. Hyper-threading is dead, where you have 2 threads per core, right? And so, there's a massive focus on power efficiency now, and re-architecting now. And so what you effectively have is you have CPUs that are kind of architected for future generations, right? Clearly Intel is trying to build for a few years down the line, and they're just setting it up now. And so what they've also done is they've also re-architected the CPU enclosure for motherboards, right? So they have 2 versions now, right? So you still have the old one, it'll still work on old motherboards, you're all good. But then you have a new one that's effectively there for higher thermals. And so this focus on power efficiency and thermals that wasn't really there previously, if we actually look at it, now you have more runway to run ML on CPU, right? I will compare it to my GPU, right? I have a 4060 in my laptop. The 4060 has roughly 12 teraflops of AI performance in it. 2 years later, right, the NPUs in these CPUs also have roughly 12 teraflops. They have 13 teraflops, but it's probably 12 teraflops, right? And so, again, right, if you just wait 2 years, the GPU, low-end GPU comes to the CPU side, and Intel's really kind of interesting. So I'm going to talk about the NPUs on the Intel side at this point, because in essence what they've done is they've effectively have so what they've done is they just, in every single Intel CPU has a 13 teraflop NPU. So obviously this isn't a crazy amount, right? And obviously it's probably going to be slower than just getting a good GPU at this point, but it is still really good as a jumping off point for just doing compute. Right? So if you say, for example, have a PyTorch model, and I don't really know if PyTorch works on these NPUs yet, but I need to double check that. But if you have like a PyTorch model, you can now theoretically run inference on just CPU. And so if these become way more widespread, what AI application developers can do is they can now just assume that the user has an NPU in them. So if you have like a desktop application that's like an AI desktop application, it's like, just assume they have an NPU. And so that actually opens up opportunities in a bunch of other non-AI specific workloads that still use machine learning, right? So like, I recently made a video about automatic background removal for just via ML. And like, if you assume that the user has an NPU on the device, you can use better background removal models that run on that NPU, and then now you can have much crisper background removal. You can have much crisper all of that, right? And so now, like, what we're moving into is effectively a paradigm where it's like we assume everybody already has AI performance, right? And so if you look at mobile, right, like if you look at phones, they've had NPUs for a while, right? You assume they use AI. Every time you take a photo on a phone, there's some computer vision that goes on there. I guess it's not computer vision, it's computer, like software image processing, but like close enough, where you take the image and then you like optimize it and do all of that, right? And so in essence, what's going on there is now you can assume that it happens on desktop. Because previously, like if you assumed you had like a low-end laptop, the low-end laptop would not have extra AI processing power. Like it would just not. Now you can kind of assume the low-end laptop has AI processing power. So if you're making applications for like desktop or whatnot, you can just be like, hey, we now have 13 teraflops of AI processing power guaranteed, because every single one of these Intel CPUs has the exact same NPU, right? And so you can say we have got guaranteed amount of flops, and so now we can build like applications that leverage these AI tools and just assume the user has it. We're not there yet because it's just the latest generation, but we can get there soon, right? AMD doesn't have NPUs in there yet, but like I assume they'll introduce them either next gen or either with like Ryzen 6 or maybe in like a Ryzen 6.5, like I doubt it'll take long. What's really interesting here, right, is the GPU game, right? So Intel, they've always done integrated GPUs on their like chips, right? And so you still have the option for integrated GPUs on chips here. And AMD kind of always, like Intel's, what they're trying to do now is they're starting with integrated GPUs and integrated computing on their chips and then expanding out to the larger cards. Whereas AMD is starting with the larger cards and putting it down onto the chip, right? So these are very different strategies. And I think, now of course, I'm wearing an Intel hoodie. I kind of am partial to the Intel way of doing things, right? I like the concept of making it work on a chip because people are buying Intel CPUs, right? Like they're buying the Intel CPUs. I guess I shouldn't say that. You don't know they're buying Intel CPUs, but like you're going to sell a bunch, they're going to happen at scale, right? And so if you sell a bunch of these integrated graphics cards, you can now optimize for those. And so when you have dedicated graphics cards that need extra investment, because everybody's going to buy a CPU, like every machine needs a CPU. But now if you have an external graphics card, now you can optimize the graphics on a CPU for whatever stuff people are doing, mostly games, AI, all the graphics type stuff. And then when the other actual graphics cards come out, they're already like pre-optimized, they work, because these new CPUs are using the same Xe2 cores as before, right? And now I guess that's a pretty good segue to talk about the GPUs. So I'm going to talk about the AMD GPUs first, because they have a bunch of new GPUs. Again, they're trying to compete with NVIDIA. But the interesting thing that we learned is that Llama 3.145B, like Meta's big chunk of a model, that is running, like for their inference, is running entirely on AMD GPUs. There is no NVIDIA in that pipeline. They use NVIDIA to train the GPUs, but not to do inference. And when Mark Zuckerberg showed up on a broadcast podcast when Llama 3 first came out, he basically talked about how Meta does a lot more inference than they do training, right? Because they're at massive scale. If you're, let's say Meta puts it, trains let's look at Llama 3.1. I guess Llama 3 is probably a better example here. Let's assume Meta trains an AP model on 15 trillion tokens, and let's cost them like 10 million, right? It doesn't cost them 10 million. That's almost something worse. Let's assume it costs them 10 million. Now, because Facebook has 2 billion users, let's assume only 100 million of them will use the LLM, right? Like if they spread it everywhere, only 100 million users will use the LLM, right? Now, you have 100 million users of the LLM, and if you're running inference, again, $1 is roughly 10 million tokens for Llama 3.8B. I guess the default there is the 70B, so I guess we should really be talking about 70B. But like if you have the 70B, and then I guess the 70, let's do 10B, right? You have 10 million tokens, right? 10 million is a lot of tokens, but if you have like 100 million regular users, that's 100 million in costs across the year. Like you're spending like $1 per user per year. And this is a free thing, right? Like you can go onto Instagram, you can go to Meta AI, you can do stuff, you can use it for inference and do all that, right? And so Meta really cares about inference costs. They don't really care about training costs, right? Whereas if you compare this approach with something like, say, Google doesn't really care about like any of these costs. Like they have such an info advantage, you don't even have to care. The only thing you have to care is to get people to use Gemini on cloud platforms. So, and it's not like super expensive. And like clearly Google does care, but like they don't have to. Because they just have, TPUs are just OP. Like TPUs are just like so powerful. Right? And so Meta, what they've done is in effort to lower costs, because NVIDIA GPUs are expensive. AMD GPUs are cheap. The problem with AMD GPUs is their software is not very good. But Meta has the best software engineers in the world. And I guess firmware engineers, and I guess you also need some hardware engineers. They have the whole thing. Meta can get whoever they want, right? And so now what you have is they can just use AMD GPUs for inference, right? And it'll be very reliable, very consistent, because they are the ones handling all of that. And so so what they're doing right now is every single instance of like Llama 3.1, 4, 5B that they're serving via Meta AI, that's all being done via an AMD GPU, right? And so that's actually really cool because now like it's proven that it works, right? So like inference, and I guess everybody's kind of trying to compete on inference here, right? Like most people, they're really trying to compete on inference, right? Like AMD is competing on inference. Intel, I think, is trying to compete on training a lot more than inference because they're talking about ML perf and all of that, right? But like Grok only does inference, right? Cerebras, they were trying to compete on training and inference, but now they're using their hardware to build their own cloud to effectively compete on inference as well. Like everybody's trying to compete with NVIDIA on inference. And everybody realizes, and all these companies are realizing, hey, we can use these alternatives for inference, but when NVIDIA is like the only chokehold for training, like model quality will suffer. Whereas Google with TPU is able to like avoid the NVIDIA like constriction, right? And Intel's really trying to place themselves in a point where they're also an alternative to NVIDIA, right? And so, in terms of the training, right? And so I guess in the AI inference space, there's a lot of companies, a lot of startups, a lot of stuff going on. Whereas in the AI training space, all you kind of have is NVIDIA, Google, and Intel, right? And I guess Cerebras also try to get into training, but like they're not really a massive competitor, right? And so of these three companies, Intel's almost the newest of the game. Gaudi 3 is again third iteration, but like also it's like more performance per dollar, but like nobody has software built around it. The ecosystem's like very new, so you kind of, if you're like a massive company, you kind of want to wait for some of that ecosystem build up. Whereas, and so I'm actually surprised, like going back, right, that Intel doesn't have more commonalities between Gaudi and like Arc GPUs, like just like, because when you think of an NVIDIA H100, right, an NVIDIA H100 is just, it's literally just a 4090 with much larger VRAM and much more compute, right? That's it. The software will work, like CUDA will work exactly the same across both and all of that. Whereas when you compare Gaudi 3 to Intel Arc, there's a little bit more differences, right? Like the software isn't fully intercompatible. And so I'm actually really surprised that Intel, what they didn't do, and I mean, the software is mostly compatible at this point. Like, don't get me wrong, they've kind of fixed most of that at this point. But like, I'm surprised that Intel, what they haven't done is made Arc GPUs just have a ton of VRAM, right? And so enthusiasts, what they do is they buy Arc GPUs. Because the thing is, most of the people who write these inference like pipelines and whatnot, they're doing it for their own custom hardware, right? Like Llama, the CPP is made by which is just some guy. It's some guy who really wanted to do this, and now it's like used at Facebook for some stuff. It's used like all over, right? So Llama CPP is just some enthusiast doing stuff. A bunch of PyTorch was just some enthusiasts at Meta doing stuff, right? And so because it's at Meta, it's like cool, amazing, right? Like it's all enthusiasts doing stuff on their hardware, not really on servers, right? And that's really where a ton of the innovation happens, right? Like if we talk about, say for example, Entropics, right, which really popped off on like Twitter and everything this past week, like where they're effectively they're using the probabilities that the model provides the output, right? Because every transformer model has probabilities on the output. They're effectively doing what nobody else thought to do, which is let's use the probabilities to detect when the model thinks it's correct versus when it's like not really sure. And when it's not really sure, you give it a few more tokens to think, right? And so you have a bunch of stuff like that where it's enthusiasts doing stuff. It's enthusiasts building stuff. And then when you have like Intel is effectively trying to segment the server and enthusiasts, which is what NVIDIA's done. NVIDIA's like, oh yeah, our server GPUs are just our enthusiast GPUs, but bigger and faster. And it's like, that's incredibly cool, right? Like you can pretty cleanly place on a spectrum like 40, 60, 70, 80, 90, H100, right? And it's like, these are the GPUs. You want, and to be fair, it's like, it goes like pretty nicely linear and then just like jumps to the H100. Like the H100 is clearly a server class card. And there's nothing in the middle, right? And that's why NVIDIA's not really expanding the VRAM capabilities of all of the consumer cards and whatnot. Like NVIDIA still has to make that separation because otherwise people are just going to use 4090s in this server and they can't charge crazy markups, right? But Intel needs to build out the software ecosystem. And then you have Google in this race, and what Google's done is Google just does the software themselves. They're like, oh, you're internal to Google and you're using PyTorch, use Torch XLA. We have the tools built, why not open source it as well and sell TPUs, right? Like Google's just like, oh yeah, we're building it for ourselves. If you want to use it, go ahead. If you don't, like, just stuck with NVIDIA, right? And so Google is effectively like, hey, here's our internal tools. There you go. Like Google's not really trying to compete on the selling hardware market, even though they could. Like if they sold TPUs, like they'd reach many more, like they'd probably had hundreds of billions of dollars to their valuation, right? And it's like TPU is such a superpower, and the only people really leveraging it, you can only really leverage it if Google allows you to. So OpenAI cannot leverage TPU, right? And so they're stuck to the whims of NVIDIA. XAI probably could leverage TPU if they wanted to, which is they're also in NVIDIA, but they're also building servers really fast, and so that's actually fine. Meta is not really in the race to leverage TPU because like they probably could if they wanted to, but they're also competitive to Google, so Google might do some stuff there. That I don't fully know, right? Like, and then the other labs, Anthropic is literally funded by Google. Like Google invested $2 billion in Anthropic, so of course they're using TPUs. Claude was trained on TPUs. Google is obviously using TPUs, right? Apple use TPUs now for Apple Intelligence and whatnot because they need large training runs, and Apple doesn't really have training grade GPUs, right? They kind of entirely have inference, and so because like, come on, like. The iPhone is not doing model training that, like, it doesn't need crazy model training power. You need to optimize for inference on an iPhone, right? And like, obviously, Apple's been optimizing for inference this entire time, and they train it elsewhere. And so now when they have to do massive training runs, they're like, oh, we need somebody to do it. Google is the cheapest and easiest to scale, right? Because the power of TPUs is scale. If you're buying one GPU, an H100 is like $2.50 per hour. It's like pretty cheap. Whereas a TPU for that much is not as powerful as an H100. But the problem is if you have two H100s, you have to deal with interconnects between them, and like that's always going to be slower because NVIDIA designs these cards to be really fast in like sets of 8, right? And so if you have 8 cards, it's like, it scales pretty linearly with the number of cards up to like 8. But then the more you have different racks, it's like really, like you have interconnect issues, and like NVIDIA cards don't really, like they scale. I'm not saying they don't scale. NVIDIA cards obviously scale. But the problem is that TPUs are designed to scale. Right, like an entire rack of TPUs is almost certainly more performant. I'm not going to say almost certainly more performant. There is a very solid chance they are more performant than an entire rack of NVIDIA GPUs. The problem is that companies can't buy TPUs. And so if you have sensitive data that you don't want to go onto any cloud and they have to stay local, you have to use NVIDIA, right? Like you cannot use TPUs for that because if you want to use TPUs, you have to use Google Cloud. And so, effectively, that's kind of what Google's kneecapping themselves, because Google has this massive hardware advantage, right? They have, like, Google is arguably still the king of AI hardware and AI infrastructure. I think everybody's still not counting Google enough, right? Like, again, I've always been a Gemini apologist. I will continue to be a Gemini apologist. But, like, Google is very much in this race. Google is the company to, like, I'm not saying they're the company to beat. A case could be made that OpenAI, or not even a case, it's probably still OpenAI or Anthropic that's the company to beat. But what Google is doing now is Google has models. And Google's effectively still doing side quests, right? They're still on side quest mode. It's like, oh, we're in a Gemini era. No, you're still doing side quests, right? Like Deepmind, they released alpha chip. They're releasing new alpha folds. Like they're doing side quests. Arguably, very important side quests, right? These are very good side quests. But like, still, like, they're all side quests. And also, the side quest one, like, Demis Hassanavis a Nobel Prize in chemistry, right? And we should probably talk about the Nobel prizes, because the Nobel Prize in physics went to Hinton and the guy behind Boltzmann machines, right? And it's like, okay, it's a Nobel Prize in physics for effectively inventing neural networks, right? And it's like, yes, do physicists use neural networks all over the place to try to decipher some stuff? Yeah, almost certainly. It's just, you're telling me the Nobel Prize didn't go to the people who built the telescope in the Antarctic that uses ice as your detector, like the ice in the Antarctic as your detector? Like, there's so much physics that went on that didn't get the Nobel Prize that I'm honestly surprised they gave it to, effectively the invention of neural networks. And the Nobel Prize in chemistry is a little bit more defensible because it's like, oh, we have a model to simulate chemicals. And it's like, you know what? That makes more sense. It's just, there's almost certainly other chemistry research going on. And the fact that it wasn't, it's still, effectively a Nobel Prize to AI. Come on, right? Geoffrey Hinton has already won the Turing Award for the invention of neural networks, along with Jan LeCun and another person I forget the name of, right? Whereas, now he's won the Nobel Prize in physics also for the invention of neural networks. Come on. If this is Turing Award worthy, this is not Nobel Prize worthy, I would argue, right? And so, back onto Google, they're still kind of on side quest mode, because fundamentally Google Deepmind's goal is not really, we want to make the most commercially viable LLM, right? That's Cohere's goal, arguably that's Mistral's goal, now that looks like to be OpenAI's goal, right? And also probably Anthropic's goal. Google Deepmind's goal is to build AGI. They're trying to exhaust all pathways to get to AGI, right? They're not, they're arguably the most pure AI lab left, right? Because they're not at a university dealing with university funding restrictions and whatnot. They effectively have infinite money from Google, so they can effectively put infinite money to research. They, arguably Metafair is also in that game, but Metafair is not really doing crazy side quests. They're on okay, it's how I think of it, right, is Google Deepmind they have Google's infrastructure advantage, right? They have the goal of AGI. Metafair also has the goal of AGI, and they have the Facebook GPUs as well. But with Fair, what you have is their research is a lot more focused, right? And then they publish everything, right? Whereas Google only publishes the stuff they don't see as super necessary. And so, because Fair publishes everything, the quest for AGI at Fair will kind of always have restrictions, right? Because if, let's say Google Deepmind does a research path, and then it's cool, we now understand how to make the model smarter, however, we can't stop this model from being racist or whatever. What happens is they just don't publish it, cool, amazing. Whereas with Fair, it's we spent a bunch of GPUs on it anyway, we'll just publish the research and not release the model. Because Fair is arguably a pure, less published research model, and that probably comes from Jan LeCun. Jan LeCun believes that science only happens when you publish stuff, right? Arguably he's a little bit of a purist there, but can't fault the raw set of stuff. Whereas Google Deepmind is we do research, we figure out how we can build AGI. Invention of transformers at Google Brain, which later joined Google Deepmind back in 2017. Guess what? That was just, hey, let's try to do machine translation better. Boom, here you guys go, right? All of this current AI boom, that's just a side quest for Google Deepmind. This is one of the potential paths to AGI. And because they have such a hardware advantage, and because they're also investing so much in reinforcement learning, because if you look at Alpha Chip, right, that was just, let's do reinforcement learning on some chips. Let's see how that goes. And so you effectively have a lab that is unshackled by material constraints, right? They have as much money as they need, they can do whatever they want, and and their focus is AGI, they're going to make AGI. I think Google Deepmind is still the leaders in the race, right? Google Deepmind is they don't have to deal with hardware restrictions in a way that, for example, Fair probably does, right? They don't have to deal with hardware restrictions in the same way as OpenAI probably does, because OpenAI is acting as if though it has infinite money, but they're losing $5 billion a year, projected to reach $15 billion in 2026. It's insane. It's truly insane, right? They don't have to deal with hardware restrictions like say Anthropic does, because Google Deepmind will always get priority over Anthropic. So if Google Deepmind is hey, all of your spare TPUs, we want to use 80% of those for our next training run in a week, right? they'll probably get it. It probably takes a little bit more internal politics than that because it's 80% of spare TPUs. Whereas if Anthropic's and so they'll probably be like, hey, can you like delay that by like a few days to like let Anthropic through? But like if Google Deepmind is like say is already using 50% of the TPUs, like Anthropic will never be able to get the rest of the 50%. Right? Like Anthropic is always second to Google Deepmind in terms of Google TPU order. Right? And it's like so Anthropic is effectively at the mercy of Google Deepmind for TPUs. Google Cloud, but like, come on, DeepMind is always first priority, right? Like, you have Cohere. Cohere is just literally a startup, right? They don't have some massive cloud provider handling everything for them. You have Databricks, who's in the race as well. Guess what? They're trying to build enterprise GPUs, but and in order to scale them up and whatnot, Databricks is not like Google Cloud TPU amount of hardware, right? Like, DeepMind is arguably still the purest research lab, and it's like they're like I think they're in the lead in a hidden way. They're just not publishing it, right? And I think they'll publish it when they hit AGI, right? Or either when they hit AGI or like, New Gemini or like something business related will force them to publish, not the want to publish, right? Like I think, because it's like writing a paper and publishing it, that takes a lot of effort, like, And so I think none of the researchers there actually really particularly want to do that. They want to like get AGI. And so, yeah, I think that's kind of it for this week's episode. Please like and subscribe. Share this video to your friends if you thought it was a good podcast. Thank you for watching, and I will see you all next time. Goodbye.